Perfect. Next slide, please. Welcome everyone to today's meeting. Today's meeting will be an industry stakeholder forum. It will be case studies and showcases of low embodied carbon buildings and materials. Very excited for all of our guest speakers to be joining. Next slide, please. So the agenda for today, we'll do a quick recap of last month's meeting. Rebecca will cover that information, and then we'll have presentations from all 5 of our guest speakers. So first, we'll start with Joe Higgin from Sublime Systems, Adam Roderick from SVP of Business Development at Boston Metal, and then Nathan Roy, Principal at Les Majors. And then we'll go into a Q&A for those first 3 speakers, and then we'll jump into the last 2. Thomas Hartman is Principal at C&H Architects, and then David Hall, a President of Hall and Mascow of the Hillside Center for Sustainable Living. And then we'll go into our second Q&A of the day. And then, as we usually do, we'll have a breakout group discussion with a prompt question, a report out, and then we will adjourn this meeting with what is to come for our last and 5th municipal cohort meeting. Next slide, please. So I will be dropping in today's workbook for you all to follow along and take notes. I will continue to drop this in as folks trickle in. Here's the link for that. I do want to add a reminder, please make a copy and do not write directly into the master's document. We highly suggest to check out the resources that are linked within the document itself. And please feel free to share with any colleagues that you deem would really benefit from the information that you collect today in today's meeting. And so I'm going to pass it to Rebecca to quickly recap from our last meeting on October 18th.
Thanks, Miranda. And hey, everyone, hope you're all doing well. For those who weren't able to attend last meeting that we had in October, I'm just going to do a very quick recap of some of the things we learned. We learned quite a bit that session. We covered a lot of material. The first kind of section of the session that we talked about was very high level greenhouse gas emissions and how to include embodied carbon. So we talked about doing a consumption-based greenhouse gas emissions accounting. Jordan Palmieri from CLF was the presenter. He went through the benefits and the constraints of doing this kind of assumption. So I've thrown a few pieces on this slide from his presentation. I think a lot of it was about how you might, if you don't have the ability to do this type of consumption-based accounting, because it is a big effort, what can you learn from other studies, right? So here, one example of a slide that he showed is from a US national average study that shows a few different sectors. You can see housing here, and it's divided between production, transportation, sale, and use. So just within that housing sector, we can see how about 35% is from the production of housing, right? So that's really the embodied carbon greenhouse gases that we've been talking about during this session. So you can go back and look at his slide deck. It's pretty dense. And we also have the recording. Then we also talked about more specifically how to measure embodied carbon at both the project level and the product level. So we talked about EPDs, how those are really great documents that you can use to compare between 2 different products that have the same function in a building. And then we looked at whole building LCAs, how you could do a calculation that would tell you the embodied carbon per square foot of a building. So we talked about the pros and cons of both of those measurement methods. And then we had Beverly Craig from Mass CEC come online, and she told us about a few really interesting Massachusetts state programs that she's launched in the recent months. The first is a EPD Kickstarter program. So this is a grant program for specifically for ready-mix concrete suppliers to get their EPDs. And there's money of up to $3,000 for each ready-mix concrete plant to do an EPD for that's then available to the consumer. There's also a embodied carbon reduction challenge, which looks at the whole building. So these are project teams can submit their building projects into this competition. The entries are due March 31st of next year, and there are a few different prizes to be had for this. And then lastly, this was not part of our presentation last time, but we have had, for those of you who have been attending these sessions, we have had a lot of discussion about concrete as a kind of one of the materials that we use in construction all the time, right? But it has a really big opportunity to reduce embodied carbon. And I know many of you in smaller municipalities may not be building large buildings, but you may be replacing a sidewalk every once in a while or repaving a road. And so I recently attended this webinar and wanted to share this link with you. I think this is an excellent kind of overview of low carbon concrete, what it looks like and how you can apply it, and also an overview of policies that exist that help either like procurement policies or pilots. So Miranda sent this link out. The link is also on this slide, which we'll send out later. I highly encourage everyone to take the time to listen to this webinar. It's really engaging and very educational. With that, unless there are any questions on that, you can drop it into the chat, but we're going to dive right on through to our presentations. And I think our first presenter is Joe. Is that right?
Perfect. Can you hear me, Rebecca?
Yeah, I can hear you. Awesome. So just you can let me know when you want to forward your slides.
Awesome. Well, Rebecca and Miranda, thank you so much for having Sublime Systems participate in these engagements. So much of climate action is just involving awareness of what levers are available, both in terms of policies as well as technologies and techniques to reduce emissions across the globe. So I really appreciate the opportunity to connect with you all in this audience. And so I'm here. My name is Joe Hicken. I'm head of policy at a company called Sublime Systems. We're based out of Somerville, Massachusetts. We have a pilot plant, which is operational. Actually, we're one of the larger tenants out of Greentown Labs, which many of you all might be familiar with. We've got a pilot plant that's capable of producing hundreds of tons of cement per year. And we've got plans to scale this technology in Western Massachusetts, and I can share a little bit more about that in just a moment. Next slide, please. So, as Rebecca was just talking about, one of the levers for climate action that a lot of folks haven't really thought about because there haven't really been good alternatives is cement and concrete in the built environment. And so, when you look at your concrete sidewalks, you look at your buildings, this material is rather innocuous, right? It comprises the vast majority of all of our infrastructure. But a lot of people don't realize that the manufacture of cement itself is a very carbon intensive process. So about 8% of the globe's CO2 comes from the manufacture of this material. It comes from two major components. One, from the feedstock. Stone itself, it's actually half of its mass is actually CO2 that's embodied in it. So when we bake it, it actually releases about half that CO2 into the atmosphere. And the other half of the emissions come from these really massive furnaces called kilns that are heating limestone to temperatures of basically hot lava in order to produce this chemical. Cement is actually a chemical. It's not really to be thought of as like a clay or something that hardens. It actually cures. It undergoes a chemical transformation. Next slide, please. So Sublime Systems contribution in this space is my boss, Dr. Leah Allison, Professor Yetming Chang. You might have come across them in the climate technology space before as it relates to energy storage and transmission. They've invented a novel process, which is an ambient temperature process, which avoids carbon capture. It produces the same drop-in. It's designed to be the same a functional material, both the way that it's transported, the way that it feels when it's wet, and the way that it hardens and results into that final product that we're all familiar with in our sidewalks and roads and buildings. And we can scale this to cost parity, and the feedstocks are scalable globally, more abundant on planet Earth than today's limestone. Next slide, please. So this is our product. It's concrete made with Sublime cement. Our process is unique in that it's a true zero manufacturing process. We're not emitting CO2 and accounting for it through some sort of net calculation. It's truly a carbon avoidance technology, which is really important when we think about what are the levers that are available to us to mitigate these emissions. Second is the company was founded on the idea that we can't bring a material that doesn't meet existing standards, existing building standards. There's a lot of solutions that are trying to get at this carbon challenge, but they've got a harder road in terms of adoption because they don't meet an existing standard that the construction industry is familiar with. Ours meets ASTM C1157. This is the performance standard for hydraulic cements. The company's concept is that at scale, we can produce this material at cost parity without a price of carbon, without any sort of additional, financial considerations. And so we're trying to bring something that really truly is just a cleaner version of the same material that we use in all of our infrastructure. Next slide. So in context, how does that we do what we do? And I've got just a few more minutes here, so I'll kind of whip through these very quickly. But in a nutshell, today's manufacturing process, about half those emissions come from the fossil fuel itself, and half the emissions come from the raw materials. Next slide. And as much as it hurts my heart to say this, no one really cares about cement. People care about concrete. And so cement's manufactured, it's milled, it's stored in silos, transported through freight and water transportation, ultimately procured by the ready-mix concrete producers with the rocks and stones and aggregate and admixtures and other chemicals, and brought to the job site and poured, where it hardens and turns into the form which is called calcium silicate hydrate. And that's the hardened phase that we all know and love as concrete. Next slide. And so Sublime Systems, we're not interested in touching any of that downstream complexity, right? There's a huge and robust and very competent construction industry that does this all very well. And so it was really important for us to really only touch the very upstream part of this process. And so ours is an all-electric process that's powered by renewable electricity, and we're using non-carbonate feedstock. So we're not using limestone in the manufacture of our lime and our silicates. And so we're producing a hydraulic cement, a calcium silicate hydraulic cement that results in the same calcium silicate hydrate at the end of the equation. Next slide, please. Don't take our word for it, right? I like to tell people I work with a bunch of Boy Scouts and Girl Scouts in terms of the carbon avoidance of our process and the lack of other externalities. That's another question I oftentimes get. If you have a third-party EP or LCA, right, a preliminary EPD, you can't get an EPD until you've got a commercial facility operating for over a year. but we have a preliminary LCA that validates that our process can avoid up to 90% of the emissions in the manufacture of cement. Next slide. In terms of sublime systems and kind of how we're scaling, how we might be relevant to the municipalities in the Commonwealth, we're rapidly scaling this, and so we have this TRL6 factory in Greentown Labs. We basically de-risked the product from the performance standards and third-party validation and the EPDs, and we've kind of validated that this process can be autonomous and run at that sort of commercially relevant scale. So we've got the site selected, and we're in the final stages of diligence on the parcel in Western Massachusetts, where we'll build out this next facility manufacturing 30,000 tons of cement per year. And would love to engage with you all if you're thinking about infrastructure. Municipalities have a critical role in climate action as it relates to mobility, but also the sort of embodied carbon in infrastructure that is being deployed. And then I'll conclude on this last slide, and I think I'm at my 7 minutes here. One more slide. There we go. Yeah, and this is really interesting part for us in terms of scaling this technology is that how do you all account for carbon in your operations? How are you thinking about your future infrastructure, embodied carbon versus operational carbon? How might you be making the case internally for investments in Scope 3 emissions reductions that Sublime Systems can help you with, and really understanding how we can fit into your sort of like larger sustainability objectives would be a really important part of the conversation that we'd love to continue to have with you all. So I'll wrap there, and unfortunately I'm going to have to miss the breakout sessions. I'm actually in Senator Markey's storage closet, a quiet place for me to get to chat with you all. But I hope to have an opportunity to chat more with you in depth if you're thinking about embodied carbon in construction of future infrastructure. Rebecca, Miranda, really appreciate the opportunity to address you all with this.
Thank you so much, Joe. That was great. We really appreciate you coming during this busy time. Are you able to stay for the Q&A period after Adam and Nate, or do you have to go right away?
No, I can stay for this Q&A session. I just have to, the hearing starts at 10, so.
Okay, so if you're able to hang tight, that would be wonderful. Then we're gonna move next to Adam from Boston Metal. And then we'll have Nathan, and then we'll do a Q&A, Joe. So hold tight. Thank you.
Awesome. Thank you.
Adam, go ahead. Thank you.
Yeah, thanks, Rebecca. Great introduction, Joe. Cement, concrete, and steel are kind of the two big elements in the built world, the two big contributors to CO2 today. And you've got a number of companies in Massachusetts working to change that. I lead business development at Boston Metal. We're over in Woburn. The company was founded there almost 10 years ago. Has about 120 employees there in Woburn today. You can go to the next slide. We are a platform technology company. The core of it is that we use electricity to make metals. We can do that with a wide variety of metals, certainly steel being the biggest and the largest impact. Though we also have a plant in Brazil where we're making using the same core technology, earlier version, to make more specialty metals. But the big impact comes from steel, eliminating the carbon emissions associated with steel production, which are right there alongside cement and concrete. 8, 9, 10% of global CO2 today comes from steel production. We believe the only way to change that is to electrify the process, and that's the technology we're developing, something that can contribute at the 2 billion ton scale that steel is produced at today. That's a huge impact. We were awarded the North American Company of the Year this year for clean tech because of the impact decarbonizing steel production can have. You can go to the next slide. There's really no steel industry in the Northeast at this point in the country, but the start of the North American steel industry was right here in Massachusetts. It's now I think a national historical site, part of the national park system, over in Saugus Iron Works, where the first blast furnace in North America was operated in the 1600s. Today, on the next slide, really ensuring that the future of really a net zero steel industry in the future is developing right here in Woburn, where we've been from 2013. We have outgrown our facility. That's a big group of our team there. So we are in the process right now of looking for a new headquarters in Massachusetts. So if anyone on the phone today has capabilities in their town for a couple 100,000 square feet of industrial / office space with some high ceilings, we've got a team looking for real estate. So please reach out if you've got opportunities there. We'd love to stay in Massachusetts as we continue to grow. You can go to the next slide. Grown the company from the early days. I joined when we were 6 or 7. We just announced a $262 million fundraising round earlier this year. The next slide shows a number of the partners standing behind us. Some local ones here in Boston, Fine Structures, the private side of Fidelity, but very global in terms of our shareholders, and really from both a mix of finance, climate, and iron and steel. BHP and Vale are two of the biggest iron ore companies, the biggest mining companies in the world. ArcelorMittal is the largest steel maker. We have end users for green steel like BMW. So excited to be bringing this technology forward with a very large assortment of strong partners. Next slide, we'll look at just a snapshot of our plant in Brazil, which again is not making steel, but we're using the same core technology and producing higher value metals. That's a plant that has early operation now and it is expanding over the next 2 years. But when you look at steel on the next slide, here is the basic equation. So the top chart, similar to what Joe was showing, these are very old processes, making cement and concrete, making steel. The basic formula for steel production has been around since the Iron Age, on the order of 1200 BC, a few thousand years ago. Carbon does an incredibly good job of converting iron ore, which is the raw form where you find iron in nature, converting that into liquid iron. But you get about 2 tons of CO2 for every ton of steel produced. Multiply that times 2 billion tons per year. Our equation, we change that entirely. We take the carbon completely out, use only electrons. It's an electrolysis process. Electrolysis on iron ore to produce liquid iron, which then, similar to as Joe was explaining, with our process, you make liquid iron, all of the downstream processing is the same. So the steel grades, the formats that you get are exactly the same as what you have today. We're just really eliminating the high emissions portion of the process, which is that first conversion from iron ore to liquid iron. Everything downstream stays the same. But since there's no carbon, you're emitting no CO2 in the process, only oxygen that's coming off of the iron ore. So if you go to our facility in Boston, which I'll show you a video here of tapping metal, the only emissions coming from that facility is oxygen. We're permitted for, contractually for all clean power. So you've eliminated all scope 1, all scope 2 from steel production using this technology. You can page forward. Here's a picture from earlier this year of one of our bigger systems, tapping metal. And we're doing, if you visit our facility, you'll stand on the other side of a window in business clothes in a boardroom. And then on the other side of the wall, you can watch the video here. So that's pouring molten steel. It's about 1600 degrees Celsius, close to 3000 degrees Fahrenheit. And again, that's the molten product produced without emissions. From there, you can alloy that, cast it, roll it, heat treat it, whatever you need to do using all the downstream processes to get the grades of steel you'd use today in bridges, in buildings, in power tools, in appliances, in automotives. But we've eliminated the first step in the process, which is where the emissions are today. Go to the next slide. This is the future of what steel looks like today. 70% of steel is produced using carbon. That's where you think of the blast furnace. There's certainly been efficiency improvements, but they've never been able to separate steel production from carbon. Steel is great in that it can be recycled almost indefinitely. And about 30% of the global market is from recycling. That will grow over the decades ahead. But the big challenge is you've got 1.5 billion tons of steel being produced today using carbon. If you're going to achieve net zero in the next few decades, that process needs to change. And that's the technology and that's the scale of a technology that we're developing at Boston Metal. Next slide. Industry is doing a lot of work to monitor that change. You've got a big binary thing in the steel industry between scrap and ore-based. So there's some metrics there. Scrap is a cleaner approach in the near term, but it's limited. If you go on the far left of the chart, kind of up high in the top left is where you'd be today with, using iron ore and carbon. But there's a lot of work in the industry to standardize how you measure emissions, how you account for that mix of iron ore versus scrap. And there's groups like Responsible Steel and others doing a lot of great work to make it easier for you and others that are the end users to understand how steel can be measured, the embodied carbon, and to push the industry forward through technologies like ours. Next slide. Just in wrapping up, so there is, today there is low emission steel available through recycling. It's limited. We are working to bring that across the, the full supply, 100% of the steel supply, to decarbonize that. You have the benefit as end users or purchasers that there are emissions standards and processes coming in place. Responsible Steel is one of those. Historically, that was a lot harder. Individual automakers, for example, had to work at their supply teams and their procurement teams to figure out the emissions between two different suppliers of steel. That's being standardized. Similar to what Joe was explaining with cement and concrete, because so much of the process happens downstream, the actual end products are exactly the same, can be very quickly tested and qualified, but you can eliminate the emissions up front. Electricity is a big driver for the process and competitiveness, but at the prices you can get from renewables today, we can be on par directly with the incumbent process. And fortunately, I think a lot of the policy elements that are in play today to support cement and concrete procurement, support steel procurement, a lot of those can leverage very similar elements just because of the way these products are made. Hopefully that will accelerate the pace of adoption. Thank you very much.
Thank you so much, Adam. Such a engaging presentation. I'm going to stop sharing my screen for a minute so that we can pass it to Nathan to share his screen and run through his presentation.
Great, thank you. And thank you, Adam. That was excellent. See if we can make this work. Ooh, wrong one, right?
Yeah, we can see your notes, the notes section. There you go.
Perfect. Now we're cooking.
Now you're good to go. Thank you.
Yeah, absolutely. So this is like the perfect setup with Adam talking about, steel, and then Joe talking about what we can do with concrete. So what I wanted to do today was share a little bit about a project we did at Boston University, the Center for Computing and Data Sciences, and chat about the embodied carbon. So my name is Nate Roy. I'm a principal with LeMeasure Consultants out of Boston. And we just completed the Boston University Center for Computing and Data Sciences with KPMB out of Toronto, Canada. We partnered with another structural engineering company up in Canada, Intuitive. So that kind of just sets the stage. I can't talk about the building and not talk about the structure too. So I'll give a short summary of what the structure is, and then we'll talk about how we were able to reduce the embodied carbon to build that structure. So the Center for Computing and Data Sciences is 19 stories, 350,000 square feet, and it's the home for the Department of Mathematics, Computer Science, Statistics. The building is arranged as a vertical campus. And it's organized in these neighborhoods by department. You can kind of see that it's reflected in the offset massing. I don't know if you've been to Boston, you've seen this. They call it the Lego or stack of books, Jenga tower. So each of these neighborhoods has their own outdoor terrace, and that's the reason for the offsetting massing. And then there's also a series of interconnecting stairs over the building height. So again, encouraging people to interact between floors, and again, reflecting that vertical campus that they're looking for. BU has a very strong climate action plan. And when we started the project, it was focused on reducing operational carbon. And that was the focus for the building. So it was focused on ways to reduce the amount of carbon it takes to run the building. So the building employs things like geothermal wells that extend 1,500 feet into the ground, heat pump chillers, active chill beams, to reduce some of the demands on the mechanical systems, triple glazed facade, and then also you'll see the sun shading to reduce the solar heat gain in the summer. BU challenged the design team. We're doing a lot to reduce operational carbon. What can we do to reduce the embodied carbon that it takes to build the building? So that was our task. So kind of before we get there, I just kind of want to set the stage on what is the building. So if you've seen it, you've seen this offsetting massing, these cantilever forms that that jut out from the building, very distinctive. If you looked at the building from above, it's very simple, the tower portion. It's 6 bays by 6 bays. In the center, 4 bays by 4 bays are continuous from top of the building down to terra firma. On any floor plate, we cantilever from 2 sides. And how do we structure that? How do we support it? We have these series of belt trusses that run around the perimeter on every kind of offset massing. So in the offset massings, either it alternates from a 2-story to a 3-story space. But we have a 2-story deep truss, and those are very simple. They're comprised of either a simple span or cantilever trusses that are supported off of the section of the building that goes all the way down to terra firma. If you think of it as a stool, that stool needs 3 supports. We get 2 supports pretty easily. We have cantilever trusses with that leading edge supported off the building that goes to terra firma. But we have the 3rd one that needs a support. There's nothing below, nothing above, right? That goes all the way down. So how did we support that? It's the next series of cantilever trusses that would either support it from below or hang it from above, and then bring that load back to our center 4 bay by 4 bay. And we repeat that process as we move our way down the building. How do we support the building? This is one of the deepest parts in Boston to bedrock. It's almost 200 feet to bedrock. And we're located in the edge of the back bay. So we have 170 feet of clay. Typically a building this size, we would have foundations that extend all the way down to bedrock. And we were really trying to minimize materials, minimize cost. So what we ended up doing was what we call floating the building. And it's really the amount of load that we take out for the soil. We dig down, that soil has a certain weight. We're going to keep our building to that weight so that it's balanced. So the soil below, the clay, doesn't know any different. It was the load that it always felt. And it was really tricky because we had to balance. We had this 20-story building. How do we keep the load as light as possible to not have to dig too deep? And we ended up digging 2 stories down about 40 feet. Our foundation is under the podium. We have a 3'6" mat. The mat thickens to 5 feet under the tower, and then under that center portion of the tower, it ranges between 6 and 9 feet thick of concrete. So a lot of concrete. And like Joe talked about, it takes a lot of energy, takes a lot of carbon to make that concrete. So embodied carbon opportunities. When BU came to us, we were looking for different ways we can reduce the carbon. We looked at the steel. Can we use higher strength steel to get the same performance to reduce the carbon? We really wanted to stay away from affecting the facade, because the facade was so tied into the mechanical systems in the operational carbon. So what we decided to focus on the most was reducing the embodied carbon for the concrete elements. Before we get there, I just kind of want to, if you saw the building under construction, I want to talk about the elephant in the room. To build this unique building, we had a lot of temporary steel shoring to support those cantilevers until the building was in place. So over 90% of that steel was disassembled, shipped back to the fabricator, and is going to be reused for another building. So the carbon it took to for that is really just the transportation to site and then back. So coming back to reducing the carbon in the building, we decided to focus on 4 main elements that represented a big portion of the concrete. The mat foundation, we talked about how thick that was. The foundation walls around the perimeter of the basement, the concrete core, and the columns. And this table here shows what your typical supplementary cementitious material replacement. So taking out the Portland cement and putting in other materials like slag or fly ash. And in Boston, elements like the mat would typically be in historically in the 40% range. Things like the foundation walls, the core, more like 20%. And what we want to do is find out, can we do better? Can we take out more Portland cement to reduce the embodied carbon? So we decided to go from historically has been more of a prescriptive approach to concrete, specifying minimum amount of cement for different concrete strengths, to more of a performance-based, where we ask, what are we looking to get out of our concrete? You know, how do we want it to behave? Strength, elasticity, workability, finish, how much shrinkage we would allow, durability. And as we take out Portland cement, put in things like fly ash and slag, it's going to have different effects on different performances of the concrete. So things like heat of hydration, early strength, long-term strength. These are all, each element may have different, has things that, constraints that are put upon it that are more important to that element. So one example is the mat. So the mat, we have a 6,000 PSI concrete mat, and we need that strength for the final condition. But we placed that mat in December, and it takes a long time to actually build the building. So typically concrete's spec'd at 28-day strength. We don't really need that concrete strength until much, much later. You know, it takes a while to actually build the core, and then from the core, we build the steel. After the steel, we put the concrete, and then we put the facade. So we really could leverage not needing that strength till later in the design, 56 and plus days. And we were trying to work with local providers. How can that help us? So how do we do this? It was really like reaching out to local concrete providers, seeing what they can do for us, and then collaboration back and forth and getting everybody in the room. So we started with just kind of this pie in the sky table, some of the performance criteria we were looking for our different elements, and then some SCM goals in trying to really take out as much Portland cement as we could. It was all, again, conversation with the owner, with the contractor Suffolk, with the concrete supplier SNF. We ran project-specific trial batches to make sure that the proposed mixes that the local providers were hoping we can get would meet those performance requirements that we were looking for. So kind of coming back to that table, we talked about Boston baseline, and then compared to what we ended up using, we were able to get 60 to 80% SCM replacements in some of our elements and still get the same performance as we would have, which was a success. So we took that information and we ran a whole building life cycle assessment to see what that reduced embodied carbon was for our structure. So both the structure and the enclosure, we use tally. And out of the structure, we are able to reduce 14% of the embodied carbon just by tackling the concrete. At the time, and so this was a few years ago, early in probably 2019, we didn't have EPDs, but by the time the project finished, we had EPDs for all of these concrete mixes. So I think if there's one lesson learned, it's just asking your concrete providers, or really any provider, to produce these EPDs, because it's really going to help push the industry forward. And here's just kind of a summary of some of our different elements and the reduction in embodied carbon based on the concrete that was used. And with that, I think this is the same slide, just breaking up by substructure, which is foundations on the left, and then superstructure on the right. And you can see here, the majority of our concrete was in that foundation mat. That's why we saved the most of our embodied carbon savings was it in the substructure, in the foundations. So I think that's it. Glad to answer any questions if you have them.
Thank you so much, Nathan. If you don't mind stopping your screen share, we can just have everyone's faces back on the screen, and then I'll pass it to Miranda to run the Q&A.
Yes, thank you so much, Nathan, Adam, and Joe, for such wonderful presentations. I do want to open up for any questions people have. Please feel free just to hop off mute, raise your hand, throw it in the chat, but definitely want to make sure you guys have the opportunity to ask these three wonderful stakeholders any questions.
I'll just say I thought all the presentations were fantastic, since maybe you just did such a great job, nobody has any questions.
That could be it.
Can I ask you all a question? If anyone would venture out, like, I would love to know how the municipal governments, right? Like, you kind of need to manage for your fiduciary to the taxpayer and the residents, your constituents, and you get these presentations from like new novel kind of technologies. Is there a way that you would recommend us engaging with you in a way that like you can engage without sort of discussions about procurement? What's the most constructive way to talk about innovation and bringing low carbon climate solutions?
So I can take a stab at responding to that. I'm Liz Galloway, work for the City of Somerville Capital Projects Group. So we're working on, manage city-owned projects. And so we're looking at opportunities to kind of do things like update our standard specifications and kind of think about getting this stuff rolled into our projects. I think that there is a little bit of a challenge with public work in that you can't have like proprietary specifications. And we haven't really gotten into doing this work yet. Like, we have some big projects that will be coming soon, but we haven't like gotten that far along. But I think, kind of like Nate was talking about, like opportunities to write like performance specifications to indicate what we want, and then let kind of the market respond with, providing us with whatever concrete that has a certain, reduction in embodied carbon, for example, but meets the other kind of performance specifications. Yeah, I think it's an interesting question because we're trying to figure out how to do that, but within the kind of rules that we have to play by. I will say that we have, the constituents in the city of Somerville are very progressive as a general matter. So we do have a lot of like public support for, when we get into building new projects, making sure that they are high performance, low environmental impact. So
That's very helpful. Thank you, Elizabeth. I'll follow up with you too.
On the projects that I've seen the most success on reducing the embodied carbon, at least in my field, on the structure, it's when there's an owner that is advocating for it. And then what I've seen is everyone will, like, from the design team to the contractor to the trade partners, they all, like, everybody wants to do better and they rally. But if the owner's really pushing it and encouraging at least to explore it, even if you don't do it, to have the information, like how much can we save? Maybe there's an added cost, but just having that information is huge. And also start early. That's another big one.
Wonderful. I see that there's a question in the chat. Has Boston Metals and Supply talked to environmentally preferable products arm of the Mass State Procurement Office and Operational Services Division about state procurement contracts?
I can speak for Boston Metals. So we specifically have not. Part of that is kind of where we fit in the supply chain. So we won't be a steel producer. We're a technology provider. So certainly we talk with the whole supply chain to educate them. But at the end of the day, you'll be procuring steel from the same suppliers you buy it from today or distributors. The difference will be the embodied carbon as it was used in our process. But for those that are interested in more education on it or would usually use that branch for info, we're happy to fill in that gap.
Adam, I have kind of a related question to that, and Joe just left, so I guess it's just directed to you now. But both Joe's product and your product are kind of slightly removed from the product that's purchased to use in buildings or road construction, right? Like, because you're up the supply chain. So for folks on this call who might be procuring some of these materials for their own municipal projects, I guess I'm wondering, how are you working with local suppliers of steel in the Massachusetts region? Like, what's your relationship with those folks, so that, and how might a purchaser who's interested in your work, use your technology?
Yeah, good question. And that comes, even though we're, quite upstream in the supply chain, we've done a lot of work across the entire supply chain, both upstream of us and downstream of us, to educate, to get people understanding what the process could look like. So I'll give, one example is we have BMW as an investor. Boston Metal will never sell steel to BMW. We'll sell our technology to a steel maker. In the US, that'd be Cleveland Cliffs or US Steel or Nucor. They would produce the steel. They'd send that to a distributor who might then send it to a tier 1 automotive parts supplier who would then sell it to BMW. We've worked with all the steps along that supply chain. So even though there's no steel production today, really, let Massachusetts know, the whole Northeast know, there are steel distributors and there are purchasing entities, and we've had hosted them for visits and met with them and kind of educated them on what's coming in the supply chain in the future, even if, again, I won't even be selling that distributor metal, let alone the end user. So there's definitely a bunch of education at this point. It's early days in terms of low embodied carbon steel. What's exciting is that I've been at Boston Metal for 6 years. Last 3 to 4 years is really when all of this is accelerated. So it's incredible to see how quickly a gigantic, slow-moving dinosaur of an industry like steel, probably the same for cement. I think if Joe was here, he'd say the same, that how quickly they're moving and adapting. And I think a lot of that is from folks like you on the end side calling for that demand and hoping that the supply then can catch up and do its part. So it's a rapidly evolving time in the steel world, and we're doing our part across the whole supply chain, and I think there'll ultimately be standards and processes in place to make that a lot easier for the end purchaser to buy steel and know with certainty what the embodied carbon in that is. But still very much a work in progress, but happening quickly.
Thank you.
Thank you so much. Any other questions before we hop into our last two presenters? Alrighty, I will pass it over to you, Tom.
All right, can you hear me? All right. So my name is Tom Hartman. I'm a principal at CNH Architects here in Amherst, Massachusetts. We're a small firm, 8 or 9 people. We work throughout New England and New York. And as Nathan said, clients enable the good work to be done. We're very fortunate. We have some really excellent clients who've challenged us over the years. And we put a lot of effort into studying and learning about energy efficiency, operational carbon, embodied carbon. And what I can tell you is we don't know very much about embodied carbon. And I'm going to show you the status of the industry and some of the work we've done to educate ourselves. This is a series of questions that I like to ask people. So let's see how many of these questions you know. This is typically geared towards architects, but you'll see as you go down the list, you may be less familiar with the question. So how many people know the miles per gallon of their car, or kilowatt, how many miles per kilowatt hour, right? Everyone knows that. You know if it's a good car or a bad car. How many people know how much in dollars your electricity bill is per month? I see a couple of hands. How about kilowatt hours per day? All right. Is an R4 wall assembly a good wall or a bad wall? Terrible, right? Well, depending, right? Who knows what the average cost per square foot of a typical house is? $250, $300 a square foot, right? These are questions architects should be expected to be able to respond to a client immediately. Is a building with a peak heat loss of 10 BTU per square foot per hour a good building or a bad building? Okay. Is a building with an infiltration rate of 0.1 CFM per square foot of shell at 75 pascals good or bad? This is where the hands real. Oh, Elizabeth, yeah, that's actually pretty good. That's pretty good. Is EUI of 40 BTU per square foot a good academic science building? And let's see here, Nate. I think I wrote down that the Boston Computing was a predicted EUI of 42. Do you have any data? Actual data?
I'd have to get back to you on that one.
I have to say though, I just have to jump in.
42.
It's not 40 if you have lab exhaust is different than a computer science building.
Absolutely, absolutely. Now here's the big one, and this is the joke. Is 221 kilograms of CO2 equivalent per square meter a good metric for embodied carbon? Is that a good number or a bad number? Yeah, it's a good number. Wow. All right, Elizabeth, you're rocking it. Now there may be other, I just can't see everyone. And the joke is 220, 221, whatever it takes. Anybody remember that movie? Anyway, so there's 3 big factors here. I'm going to back up: operational carbon, embodied carbon, and sequestered carbon. Drives my wife crazy that we call it embodied carbon, because you would think that's a good thing, but it's not. Embodied carbon is not a good thing. I think everyone on this call already knows that. But operational carbon, year to year, what it takes to operate the building. Embodied carbon, what's already emitted in the production of materials. And if it's a negative number, that makes this sequestered. Sequestered carbon, how much can actively be captured and stored in in materials from the atmosphere, rapidly renewing materials. How much does a forest sequester in carbon per year? So really understanding the balance of these, because if you use a huge amount of operational carbon, huge amount of materials to save a small amount of energy, you did more harm than good. Okay. So it's really a balancing act, because if you have a project and it's not using a lot of energy or carbon to operate, well, how you intervene into that building really matters. If it's using a huge amount of energy, it may be that it's addressing the energy system and not the envelope of the building itself. It could be an energy choice. So it's balancing, and I practice what I call architect's math. I don't use decimal points. We need to have information that is good enough to make clear decisions. This is the stage of carbon through production, maintenance, use of life. What's a good building and what's a bad building? And I also want to say, we need to train ourselves to think in kilograms per square meter, because that's what the rest of the world is using. That's how EPDs are presented. And we need to train ourselves how to do that. The same way that we understand miles per gallon in a vehicle, we need to get there with buildings and carbon in those metric units. A heavy building, concrete, large steel building might be 6 or 1,000 kilograms per square meter. A renovation, 150 to 300. So 221 is a pretty good building. Just for reference, 1 pound per square foot is 4.8 kilograms per square meter. So just learn that. But the problem that I think we have as an industry is we don't have this in our belly yet. You know, it's an intellectual exercise. And the industry at large of architecture and construction is made up mostly of small firms, okay, in the architecture profession. So if it's a 150 person firm, there may be 1 or 2 people whose specific job it is to learn this and become fluent in it. But we have a huge uphill battle. AIA, I was a strategic council member for AIA National for Massachusetts for the last 3 years. We did a survey, and only 1/3 of our members have confidence, 96,000 members. Only 1/3 of the members have confidence discussing carbon with their clients. Okay, that's a problem. That's a huge problem. If you're a client and you ask me about the building code and I say I don't know, you go to the next architect. You find someone who can actually communicate the way you're looking to be provided service. How often, and this is a national discussion, how often do your firm discuss environmental impacts of project decisions with your clients? It's in our code of ethics, for God's sakes, for AIA. Rarely, you know, so I don't need to get into where geographically this could be in the country, but you can see that those clients who are on the front line of thinking about embodied carbon and challenging their design firms, nationally, we're way, way, way behind. And Massachusetts is pretty far ahead on most every metric, which is great. I also see Joshua from the city of Northampton here. Joshua, nice to meet you. So this is a study that we put together this summer with an amazing intern, Molly New, from Smith College. This is a project at Smith College. I would offer to you, if any of you are interested in incredibly smart, talented interns, contact Smith College, the Praxis intern program. Smith pays them for the summer and they work with you, and, you know, special projects, whatever. We've had several of them, really amazing. So this is Molly's work with me standing on the side asking questions that I don't know the answers to. So this is a building that was built in 1878. Up here, this is embodied carbon. Down here is operational carbon. It's an interesting building because it began with a coal boiler, a central coal boiler in the building, as well as pot-belly coal boilers in each bedroom. It had a series of upgrades in 1916. It got electricity installed, sprinklers in the 50s, bathroom upgrades, and we did a significant renovation in 2020, which took the building off of the fossil steam system and set it up for low temperature hot water and cooling. Smith is currently in the process of installing ground source heat pump district-wide system, which will drastically reduce our operational carbon. We're involved in several of the dormitory renovations that are doing this. This is Washburn House. This is what it looked like when we took the project. You can see that there was a porch here once upon a time. So we rebuilt the porch and we tucked in an accessible ramp. This was designed by budget. So we could have done a lot more, but we had $4.2 million to work with and we got the most out of it. So we did look at, do we insulate the walls? What's the impact of that in terms of operational carbon? How much embodied carbon goes into that? Is it worth doing? How does that compare to the proxy price of carbon? Because if I spend $1,000 to save a metric ton of carbon, that's a really expensive way to save carbon. Is there a better way to spend that money more effectively? And that's, as designers, I think one of the primary questions we need to ask. So this is embodied carbon over time, 1878, the original build. And then you can see the small renovations come along through time. And then this is our renovation right here in 2020, okay? I think it's important to say when Molly came to us this summer, she didn't know much about this at all. She was able to dive in and focus on taking the embodied carbon classes, the Zoom classes that the Boston Society of Architects put together, reading various books, looking at Tally, looking at various software. She probably had 800 hours this summer that she put in working on this. And it culminates in a report. But this is a diagram that I think is really, really quite wonderful. In green, it's the embodied carbon. So here we are, 220 metric tons of carbon to get it built. And then the blue line is the operational carbon. You can see they put in a cogen system. And now once they're going to go to electrified ground source heat pumps, that operational should be very, very low. This is our renovation. So we made the second biggest bump. But we also set the building up for the next 100 years. And I think that's an important contribution. So here's the big takeaway. Over the life of that building, 1/3 of the total carbon is embodied, 2/3 is operational. Again, that operational is going to go way down in the future. None of the products we used included sequestered carbon. Okay, so not everything is an add. The renovation was about 150 kilograms CO2 per square meter, okay? And a new low carbon, high efficiency building is somewhere around 260 based on the CARE tool, sorry. So just to put this into our bellies, right? So the original construction, 1878, 207 metric tons, most of that is the masonry. That's equivalent to a full flight one way from JFK to LAX. Okay, that's how much carbon that is. Right? Can you imagine how much fuel that is, what that takes? That's, 6 hours, 7 hours of just a jet flying. The renovation was 105 metric tons, and that's the equivalent of 1 acre of New England forest over the life of the forest, 140 years or something like that, or approximately 250 acres in 1 year. 0.4 metric tons per acre is the number I'm getting. And so to try and put that into perspective, that it's going to take a long time for that to be sequestered by a forest. But I think that's an important metric for us to start to understand not only the expended amount of carbon, but what is required to sequester that. Lastly, I think the most important thing for our industry and for government to do is to monetize carbon. Okay. So as I mentioned, if I spend $1,000 to save an avoided metric ton of carbon, that's pretty expensive. I think it was $51 a ton during Obama. It dropped to $5 during Trump. It went back up to 50 or 60 under Biden. I think they're currently talking about $160 a ton. Okay, so what we did is we took a new building, the renovation of our building. We took the difference in metric ton that we avoided by renovating the building, intellectual exercise. And then we applied it to these rates. So at $190 per metric ton, this would yield an incentive of $97,000 for a $4.2 million project. That that's a non-starter. You know, $26,000 wouldn't even cover the fee to do the study. But if we get up to $700, $800 a metric ton as an incentive, then we're talking about $360,000. So if an owner has a choice, I mean, most of my clients are institutional clients that have had their buildings and they're not going to sell their buildings. They're not going to tear down their buildings. But if we want to actually reduce embodied carbon by enabling owners and architects to make decisions, it's much easier to knock down a building and build a new one, I promise you. But if I bring 10% or so of the project value to a client, it changes the thought process. Already there's historic tax credit programs that provide 30% of the total project cost. If you work with the National Park System, this could be an adder on top of that, so that it could really be quantified. And I think this is the thing that really needs to move the industry. I also think manufacturers who can demonstrate that their product is reducing the embodied carbon of their comparable products should benefit from some sort of a tax credit. It needs to be heavily incentivized. And what I promise you is, as soon as there's money on the table, everyone will learn the units. They'll get them in their belly, because that's what needs to happen, right? So it's I think, an important driver in making this possible. There's a long way to go for the design and construction industry to become fluent and literate with this. We're at the very beginning of this. And I also just want to caution that I don't think the way, this is my personal opinion, I don't think the way to advance this is to legislate it as a requirement for the building industry, as perhaps an energy code would, because it's extremely, it's a burden on small firms who may be given another thing to do they don't get paid for. And if it's incentivized, I think that it will be much better received and impactful than if it's legislated upon the industry. Thank you very much.
Thank you so much, Tom. Our next presenter is David Hall for the Hillside Center of Sustainable Living. And David, I do have your slides on my screen, so just give me a moment to pull my screen up, and then you can tell me when to advance.
Okay. Can everyone hear me okay?
Yes, we can hear you.
Oh.
Great. Thank you.
Okay, my name is David Hall, and I am a partner in Hall and Moscow. The Moscow portion of that partnership is Keith Moscow, and he and I have been working on this sustainable community for about 10 years. It's located in Newburyport, Massachusetts, and we've integrated into this community permaculture-focused landscaping. That is, in shorthand, edible landscaping. Focus on electrification of transportation, shared vehicles, and of course, very low operational carbon. Can I get the next slide, Rebecca? Going back to the roots of this project, Pathways to Zero was a grant program DOER set up 3 or 4 years ago. And I just want to acknowledge their help in making all this work. They assisted us in creating the energy modeling for the project. We are Passive House certified in 3 out of 4 buildings thus far. The big news, go ahead and give me the next slide, Rebecca, is that we previously were building a wall panel that combined EPS foam and concrete. We had hoped to collaborate with Carbon Cure out of Nova Scotia, but there were no ready-mix plants that adopted their technology, which basically takes industrial waste CO2 and injects it as frozen crystals into a ready-mix truck just before it leaves the plant. But there were no such ready-mix operations in our area that offered that. So we were we had a huge carbon footprint. So we went completely in the other direction. Go ahead, Becca. And we went to hempcrete, hemp lime wall panel technology. And this is an industrial hemp plant that is carefully harvested and processed in a decording operation. We take these dust-free bales of hemp fiber, we blend them a yard at a time with a binder, and then we use compressors to fire them into our cribs, our wall panel cribs. Now, in a perfect world, we would have used no steel, but because we were taking these risks or in building in a manner that I don't believe has been done in stateside and much in Europe, we did use some steel in the frame so that we didn't get distortion or torsion during the tilt-up process. How about the next slide? So, yeah, we went all the way to the other end of the spectrum here. This is a gable wall panel. It's about 29 feet top to bottom. We set all the window units in the walls. And then we insert the hemp fiber. Now, this has what's called a lot of rebound on the top of it now from the shooting. It creates somewhat of a snowstorm, I should say hemp storm, when you're shooting this stuff. So a lot of loose fiber will migrate around your space, and that's why you're seeing these deposits on top. Next one. This is that same wall. This has a plaster applied to it. And I have to share with people that it is a very, very unique wall assembly. You basically have 14.5 inches of plant fiber, which is nothing but hydrated lime and plant pieces. And then on the outside of that, there's no rain screen, there's no drainage plane, there's no vapor barrier. On the inside, there's no sheetrock. All you do is plaster using natural plasters on the interior and the exterior. There is some of the old conventional taping between your window unit and your wall plaster skin on the exterior. And I don't believe anyone's tried to build a 12-unit apartment building with hempcrete yet in the US. So we've just finished shooting 1,600 bales of material, and we just did our first tilt up a couple of weeks ago. We have another one coming online next. Important to know that this wall assembly using hemp fiber sequesters approximately 10 pounds of CO2 per cubic foot of wall. So we're tucking away and putting to bed about 10 pounds of CO2 for every cubic foot of wall. And our project, therefore, will sequester something like 75,000 tons of CO2, which is not bad. In our next building, which is a 20-unit building, we will be able to free ourselves of a lot of steel, and we'll be able to accompany that with CLT as cross-laminated timber technology. And hopefully we could work with Sublime so that we really are, I guess you can't say anymore, you're cooking with gas. But you are making a big, big difference now by combining plant fiber with in this manner, and combining it with the amazing technology in the steel industry and from Sublime that we've heard about today. Next slide. Yeah, here we are down at the bottom for emissions. we're in the green, so to speak. Straw bale is the only other technology, I believe, that is as efficient or in sequestering carbon. In fact, it's quite a bit more effective. It has its limitations. Next slide. Here we are. We've tilted up 24 panels 2 weeks ago on the south side of the building. It went extremely well. We're really delighted with it. What you're seeing is the inside frame of the wall systems. The other reason that a steel component was reassuring, I will say, is that we knew that we could get good connections between wall panels, both bolted and then welded, and we wouldn't have to worry whatsoever. So the next slide, I guess that's it. I wanted to keep it short for everybody. I am more than happy to give folks tours if they would like to see the Hillside Center for Sustainable Living. That's the link right there. I want to add that I'm actually Zooming with you guys from the Northeast Regional Biomaterials Conference in Boston right now, and I'll go back to breakout groups. And it is exciting that people understand the importance of purging our building, our built world of carbon as we assemble our buildings. And I want to thank Miranda and Rebecca so much for putting this all together.
Thank you so much, David. So inspiring what you're doing. And thank you, Tom, for your presentation as well. I think I don't see any questions in the chat yet, but let's open it up to the group. Feel free to unmute. Let us know what kind of questions you have. I know it's been a lot of information today. Quiet group today. That's all right. I'm wondering if anyone has reactions to Tom's suggestion of what did you call it, Tom?
Monetizing carbon.
Monetizing carbon, yeah. What do y'all think of that? Feasibility of that? Thoughts?
And a good example is RGGI, Regional Greenhouse Gas Initiative.
Mm-hmm.
You know, that's my thought on this is all these structures already exist. You know, and trying to monetize it. People will learn. It'll move a lot faster than if it's a boutique kind of approach. Which in some ways, if you look at the dollar value of construction and what a small percentage is actually being affected by people's good work, it's tiny right now. And hear me well, Massachusetts is way out there in front. You go talk to your colleagues in the southeast portion of the United States, and it's a totally different situation. So,
I did have a question about your presentation, Tom, regarding the carbon price that you were talking about. Were you suggesting 160, or were you were saying that was the current price and you were suggesting something higher?
Yeah, I believe the current cost per metric ton is somewhere around 50 or 60. I believe the federal government right now is talking about raising that to 160. But that still doesn't really move owners to make decisions that they may not be readily able to make. I mean, you know, it's amazing when you have an incentive program how the design parameters are broader for you. as an architect. So I think it really is that, again, if it's a $4 million project and I bring an owner $20,000, forget it. If it's a $4 million project and we bring $400,000, 10%, it's a real motivator. And I think many owners are already doing good work that they should receive benefits for this.
I see a comment from Brenda that the Birdo does that with alternative compliance payments. Brenda, I'm wondering, maybe you can come off mute and just talk a little bit more about what you know about Birdo.
Sure. I just heard developers talking about using that alternative compliance payment as a point of comparison. So if the new design that reduces operational carbon will cost some extra amount, they compare it to what they would have to pay for alternative compliance payments for doing nothing new. And that's been helpful to convince leadership.
That's great, thank you. And David, I had a quick question about your hemp.
Yes.
Whether or not, I saw that you said that it could be harvested in Massachusetts. Are there many hemp farmers right now, or what's the industry like locally?
Well, that's a really interesting question. And this is, you'll cringe when you hear this, but we have not in the US perfected hemp for the particular system we use for inserting it into wall panels. So we need a dust-free, very consistent, roughly 1 inch long fiber, which comes from the stock. There's an outfit in New York State who's gotten, they're proceeding, they're getting better at it. So that's our closest neighbor right now from whom one could buy hemp fiber. There's a lot to it. The farmer himself needs to be involved in understanding all the elements of this. This is a French device. It's a fairly simple piece of equipment we use, but they have perfected this system. So every bale of fiber we get is immaculate. It's perfect. And so growing takes a lot of knowledge, and then the decortification of the fiber, there's a lot to that as well. We're getting there, and New York's our closest resource now, and it would be very exciting to see this industry respond in our agricultural areas of Mass. It'd be really great.
Thank you. And I see Joshua, you have your hand up, so go ahead and ask your question, please.
Thank you. I guess I had two things. One was on the carbon, embodied carbon tax. In theory, would that be on all new building, or would that just be on renovation versus building something new in the same place? Because I feel like there could be issues with that when it comes to like sustainable housing, or not sustainable housing, but low income housing and things like that, because we do need more housing in the Northeast. But I guess could encourage housing in buildings that already exist. And secondarily, for the hemp building, do we know what the lifespan of these materials are? And would that come into account for the embodied carbon that's in them for the lifespan of the material?
I'll take the first part. Don't say tax. Say monetize carbon. Because tax just wrong direction. I don't know how it would be written. I don't know how it would be done. It needs to be done. It needs to be thoughtful. It needs to not be a shell game. It needs to, it needs to not be someone modeling a crappy building and then saying, oh, look how much better I am, which is typically what happens. I also think it should come down in some ways to weights of materials. Buckminster Fuller, madam, how much does your house weigh? And I don't know how it will play out, but I think that some thoughtful approach to this with the industry players, all the participants in the industry, can craft something that's appropriate for Massachusetts. I don't have much hope it would go nationally, although it should. But I think within Massachusetts confines, we could do something that's very thoughtful. I mean, we have an incredible building stock here, and maintaining that stock could be a game changer. Just one small example: we did a project in Lawrence, Massachusetts, in 2008. We started it, Union Crossing mill renovation, 125,000 square foot mill building. We put 60 units of housing in it. Low income tax credit, new market tax credit, historic tax credit, DOE grants for high performance buildings, alphabet soup. We could have easily accommodated one more program to yield another $500,000 for the project that would have made it that much better. And so I think there's hundreds and hundreds of examples of projects already happening in that similar vein.
Thank you.
Thanks, Tom. And I see David has dropped off. I know he is at a seminar, all day long seminar today, so he may have had to jump off, but I'll maybe reach out to see if he has any follow-up info on the lifespan of those hemp wall panels for you, Josh.
I would offer easily 100 years. As long as that material stays dry, there's no reason it shouldn't be there for a long time.
Yeah, very long lasting.
Great.
Well, thank you. I don't want to keep our speakers any longer. I know it's been a lot for them. So thank you so much. Those who are still with us, Tom, Adam, Nathan, thank you guys. We do have 30 minutes left. We had planned to do breakouts